Hi, I'm going to do a super quick overview of AR, VR, MR, XR, all working in the web. Possibly the quickest one I've done, so forgive me if I generalise a fair bit and skip over some complex and deep parts, but happy to chat offline if anyone wants to know more. So I guess a little bit about us. We're a team of 14 who've spent the last 10 years or so working in the AR and VR space. So in 2009 we built the world's first augmented reality content management platform that enabled non-developers to create and publish content to the native AR browser apps like Layer and Geneo. Mateo, who developed Geneo, were later acquired by Apple, and the team and I guess the underlying tech behind ARKit that was released by Apple in September last year. We're headquartered in Wollongong, just near Sydney, with team members across Australia, Indonesia and Poland. But we've always been web people and we absolutely love the web. So for us, the web is really, the largest platform in the world. It's got the highest number of developers and content creators and the largest audience. And it's really democratic, so it's really open and inclusive. And when you look at how many people can use AR and VR now, for HMD, so it's head-mounted display only apps, the end of last year was about 26 million. Mobile AR and VR apps was about 2 billion people had the capability to use it, so they had devices that they could download and use them on. And on the web, you've got over 3 billion installed web browsers on different devices that supports using AR and VR content directly in the web. So basically we developed AWE, so it's AWE. So it's an entirely web-based creation platform that enables non-developers to easily create image and location-based augmented reality, virtual reality and 360 interactive experiences. And these can be seamlessly woven together to create rich, immersive experiences. And if you're a web developer, you can easily add your own CSS and JavaScript to extend those experiences further. And we've done that to really, I guess, minimise the time, effort and cost to create VR and AR, and also because a lot of people aren't actually developers. So with head-mounted display-only apps and mobile-only apps, you've got to be a developer or hire a developer. Can read through the steps there, but there's a lot of different steps to create those apps, a lot of time taken to do them, and generally you've got to do that each time for each different platform you want to target. With or with web-based AR and VR, you literally create it once and it works across all of the different browsers and devices. If you look at how to view it, basically, people don't need to download and install any native applications. So it literally just works across smartphones, tablets, computers, head-mounted displays, VR goggles, AR glasses, that type of thing. By just simply clicking on a web link, URL, and it opens in the web browser on the device that you're using. And then the content automatically is adapted by the AWE platform to the device form factor and any specific browser quirks. So it literally just works. I'll now show you a quick video of Milgram's continuum, and it illustrates the different modes and all working within a web browser. This was done a while ago, so note that where the image marker is shown, or the fiducial marker, AWE now supports full image recognition and tracking in the web browser. So that means you can bring literally any image to life. So here's an example of Milgram's mixed reality continuum, showing 4 main modes that make up this continuum, from reality on the left-hand side through to virtual reality on the right-hand side, and the 2 modes in between. If we look at what is presented to us, this is a virtual scene, so a 360 or VR type of experience with some virtual objects in there that you can interact with. You can place it into stereo mode, so you can experience this in a head-mounted display as well. To the left of this we see augmented virtuality, which is the same type of scene but with sensor data. So the camera view in this example is projected into the scene, and the sensor data can be anything that you like. On the far left, so showing now, is just plain reality, so a standard view of the real world, or the fleshy meat space that we live in. And if we hold up markers there, nothing happens, it's just the real world. But if we turn on augmented reality just to the right of that, we can see that tracking is now possible, and the digital content is now overlaid onto the images and objects that it's seeing. And it uses computer vision to do this. But because this is just one type of sensor data, we can project this into the augmented virtuality scene as well. So if we hide that, it allows us to use that to move the marker content around inside the 3D virtual space, like what you're seeing here. And we can use other sensor data in this context as well. And if we go back to the full VR environment to the right of augmented virtuality, we can see that now we've seen the 4 main modes all working entirely within a web browser with no plugins, and it can work across smartphones, tablets, head-mounted displays as the output channels of those as well. So mixed reality is a really good term, it's a great term, but Microsoft did almost too good a job at marketing the HoloLens, so many people now associate mixed reality with just HoloLens. So competitors in Silicon Valley, which were led by Qualcomm really, have rallied around a new term, which is extended reality, or XR for short. But this effectively means the same thing. XR has now been adopted on the web, so starting in a proposal initiated by Mozilla, which makes the ARKit and ARCore tracking available to web browsers also. And now all the standards development effort that was going on with WebVR has evolved to focus on the broader WebXR strategy. So we'll take advantage of that once it's stable, but this is likely to probably take another year or more before it becomes a standard part of the main browsers. Meanwhile, you can use 360-degree media, VR, location-based AR and image-based AR like this in all platform right now. So I'm going to show a super quick video, and it shows image recognition and tracking working inside the web browser. So this one's on an iPhone running Safari, and in this example it illustrates multiple images being recognised and tracked without having to rescan each image to initiate the content display. So you just go to a URL, point your phone at the images, and this shows really that you're no longer bound to using those fiducial markers or images with markers around them. You can literally use any image you like. And you get the idea there. So the majority of our customer base is in the kind of education, cultural and civic sectors, especially around that kind of K-12 and tertiary education. And we're really seeing the Asia Pacific region now starting to explore the opportunities around these technologies created and delivered in the web, so not just through native apps. So thanks very much for having me, and any questions, my contact details are there. Thank you.